This video is going to go over the circuits that I've completed so far in my project, which are going to be the power circuitry for the board and the SD card circuitry. But first of all, I want to introduce this first page, which contains the two board-to-board mezzanine connectors. These, for now, I have connected the 5 volts that the SOM needs and the ground, and also some few other things that I'm going to talk about. The pinout for this, for these two connectors that are connected to the SOM are given in this document, and as you can see, these first few pins are VDD 5 volts. There's also the voltages for the reference of the banks. So 500, that's bank 500, set at 3.3, 501 at 1.8, and then there's bank 34 and 35 for the PL, as I remember. This page of their schematic also shows that you need to provide 5 volts for the SOM. And in fact, actually, you only need to provide 5 volts for the SOM. As I said in the previous video, the rest of the voltages are created or generated on the SOM itself. So this makes stuff really easy. You just provide 5 volts. This is going to be their circuit, their power circuit for the dev board, which I'm going to be pretty much using. First of all, the power connector here is a barrel jack connected to a switch, which switches between the barrel jack and a terminal block. Then there's a 2 amp fuse, which is kind of confusing because the board needs 3 amps. I guess 3 amps is an upper limit, but I still don't understand why they would use a 2 amp fuse. This is an ESD diode to protect against electrostatic discharge, and then you have some bulk capacitors, and you get 12 volts here. This 12 volts goes into here to this buck regulator. This stuff happens. You can read the data sheet, but basically you get 5 volts here, and then that 5 volts goes to the SOM, as I said, and then this board waits for the SOM to generate its voltages, and then when the SOM generates its voltages, it sends, or it pulls the system PG signal high, which enables this regulator, and then we get 3.3 volts. If you look at my circuit, you're going to notice that it's pretty much the same, but there are a few differences. First of all, in the previous, or in their design, they just connected a resistor to the EN pin as kind of a protection for the EN pin, but this is not ideal. I added the same resistor and also an RC circuit. My board also uses 2.2 microhenry inductors. I'm pretty sure theirs uses 1.5 volts. I'm not using a terminal block connector I don't see why I would need that. I just used a barrel jack, a 3 amp fuse, the same ESD diode, the same bulk capacitors, and I get 12 volts here, which go into the both of these regulators. The startup sequence is also obviously the same because I need to use their system PG pin. Something else, I added these LED indicators. Now, I wanted to add a system PG LED, but the problem is that this signal has a 1 milliamp Zynq current, so I'm not sure if it's going to be able to drive an LED. I can add a transistor as I put the note here, but I don't know, it might just complicate the design, and if I'm gonna just add a whole new component solely for this LED, it might not be worth it. So And also at the same time, if 3.3 is glowing, then that means the system PG is also good, so this might just kind of be obsolete anyway. Moving on to the SD card circuit, I have this SD card connector and the data pins of the SD card, which are pulled up high for signal integrity, as well as pulled low via these ESD diodes for protection. These diodes are different than the one in the power circuit because that one is rated for higher voltages. This one is rated for about 5.3 volts, but the signal here is 3.3, so it's going to be good enough, I think, hopefully. Yeah, the voltage of the SD card is 3.3, but the bank that uses, or the bank that is configured to use the SDIO controller, which is specifically the SDIO 0, which exists on multiple sets of pins. But the problem is that only one set, so one specific group of pins is configured to for booting. You can only boot using these pins, which are the pins I'm using. As I was saying, the bank voltage is 1.8 volts, which is obviously different from the 3.3. So that's why there's a voltage translator. This just translates the voltages so that the SD card can talk to the FPGA, and the FPGA can talk to the SD card. The two other signals are the SDIO CD and the SDI WP. The SD one is the SD. SD is short for chip detect. So whenever there's a chip inside the connector, this gets pulled high, as far as I remember. And the write protect protects from writing to the SD card. My connector does not have the pin, so I'm just going to pull it low in case I messed this up and it actually needs to be pulled up high. I place this 0 ohm resistor in the schematic, which is not going to be placed in on the board, and it's going to be pulled to the same voltage level as the bank. Finally, here I have the boot mode 0 and the boot mode 2 pins, which are responsible for selecting the type of booting we're going to be using. Basically, this is a standard 2.54 millimeter header pin connector, and if you move the jumper here, you short these two, then you're going to boot with JTAG, and if you short these, you're going to boot from QSPI, and then if you do these, you're going to boot from SD. I want to also talk about a few circuits that I'm kind of stuck on. For example, this USB JTAG/UART programming and debugging circuit using this FTDI chip. I know how to design this chip because, this circuit, because I saw Resd, or REHSD, I don't know how to say his name, which is a YouTuber who is doing a similar board as mine. And the Zynq, I believe the Zynq has this circuit public for this kind of programmer. But the problem is that I'm not sure how I'm supposed to configure the channels of the FTDI chip. Basically, what you would want to do is configure this one to be JTAG and this one to be UART. But the problem is that you need to use Xilinx's program FTDI utility to program the FTDI chips so that it shows up in Vivado, but at the same time you need to use something called FTprog from FTDI to program the chip so that you configure these pins, or these channels specifically. The problem is that if I use FTprog, it's probably gonna erase the configuration of the Xilinx utility and vice versa. So I'm not sure what I'm supposed to do, and there's basically zero documentation for this. So if anybody knows, maybe write down in the comments. Finally, I want to talk about one more thing that's kind of confusing me, is the way I'm supposed to use two connections for the same thing. For example, for JTAG, I want to use the header pins and the USB, which this Zybo board does. It has the JTAG pins for the header pins, and also at the same time they just connected the output from the USB FTDI chip here. My question is, what's stopping me from just connecting both? I guess that would create an issue. That would be my guess. Also, circuit also does the same thing for JTAG. There is a connection between the header pins and the FPGA, but at the same time there's a connection to the FTDI chip. So what's stopping me from connecting both at the same time? Something else is the JTAG, the whole JTAG scan chain in the independent mode. I've read the documentation, but I still don't understand what it is exactly. As far as I understand, and I'm gonna show the documentation for Xilinx and my board. My board has these boot mode selection pins, which select between QSPI and SD and JTAG, and here it says select independent JTAG. But the problem is that I'm not sure how I'm supposed to choose between independent mode and JTAG mode, and I'm not certain which one my board uses, even though it says independent here, because on this line it says, under jumpers, it says one JTAG selection for using PS and PL, reused or independent JTAG configured through PL pins. Now, as far as I understand, independent mode is only for the PS or the PL. I mean, one of them. That's as far as I understood. And here it says that the board, you can basically configure the JTAG to be, the scan chain to be cascading or independent, but according to this document you need an MYO2 pin to select between cascade and independent mode, but my board only uses these two pins. So how am I supposed to configure JTAG to use cascading or independent if this is not accessible? What I know for sure is that my board uses these PJTAG pins on the PS, which also I'm going to be using, but the problem is that I'm not sure if the PJTAG interface, if you can access both or enable both cascading and independent modes with it. Here this diagram shows that the MIO PJTAG pins access the DAP and the TAP controllers, but it seems that the cascade and independent signals only go to these here. That's as far as I understand. So I don't know, these are my questions for the FTDI and JTAG circuits. So if anybody knows the answers or can correct me, please comment down below, and see you next time.